Hello, welcome to Math 1324. This is Chapter 4, Section 2, Example 2. In this particular question, we want to use the simplex method to solve the linear programming problem. We're going to maximize this objective subject to some constraints with, of course, x1 and x2 being greater than or equal to 0. We need to go ahead and put this into its into the initial simplex tableau. To do that, however, we need our system. Notice that we're going to have two different slack variables. So it'd be an S1 and an S2. And converting these, that's going to give us 4x1 plus 3x2 plus S1. Now, I don't have any S2s or the zeros for this equation, and the z's, and all of this is going to equal 7. Then for the next one, we have 1x1 plus 2x2, no S1, plus S2, no z, is equal to 4. Good. Then, of course, for the objective, make sure we move the 16x1 and the 3x2 to the left, making that negative 16x1 minus 3x2 plus 0s1 plus 0s2 plus 1z, then all of that's going to equal 0. Outstanding. And to create the actual initial simplex tableau, we simply need to put this into a matrix. Just a reminder, 1, 2, 3 rows, 1, 2, 3, 4, 5, 6 columns. So this will be a 3 by 6 matrix. So this will be 4, 3, 1, 0, 0, 7, 1, 2, 0, 1, 0, 4, negative 16, negative 3, 0, 0, 1, 0. Awesome. This is the initial simplex tableau for this linear programming problem. Good. At this point, we need to use the simplex method, which means we need to figure out what is the pivot. Now remember, the pivot comes from indicators first. So looking on here, the indicators are these 4 numbers, not including the 1 or 0 here. We're going to look for the most negative indicator, in other words, the smallest number, which would make this negative 16. So negative 16 indicates that x1 column is in fact the pivot column. Then we need to look for the pivot row by doing division. Remember, it's the equal column divided by whatever number's here. So 7 divided by 4 would be 1.75. 4 divided by 1 would be 4. Then the smallest of these two numbers that are still positive, remember, if you get 0 or negative or an error, meaning you're dividing by 0, don't worry about those. That will never be a pivot row. But we're always looking for the smallest, so it's going to be right here. That means that the pivot row will be that right there. So remember, you have to do the column first and then the row. And then the intersection between the two will be the actual pivot. Now notice that that would be row 1, column 1. So that's what the element number that is, row 1, column 1. Awesome. And at this point, we need to go to our calculator to use the program of pivot. I'll see you there. Welcome back to the calculator. Now, in here, I still have the previous A and B. It doesn't matter if they're there or not. It's up to you if you want to get rid of them. If you want to get rid of them, just do second mem, and then memory management, and then manage your matrices, which is number 5. And to get rid of them, just press delete for each one. And notice that they're gone. So if I go back to the home screen, then go back to matrix, notice that there's nothing there anymore. Okay, for edit, go to matrix A. We always go to matrix A for our first matrix here. Now, just type in our initial matrix, and it had a size of 3 by 6, and then we'll type this in. 4, 3, 1, 0, 0, 7, 1, 2, 0, 1, 0, 4, negative 16, negative 3, 0, 0, 1, 0. Good. Quit to the home screen, and then I do like to inspect this to make sure that I typed everything in correctly. It's very easy to mess this part up. I'll be very honest with you. If you make a mistake, it's very likely going to be in here. Well, or the other 10,000 places you can make a mistake here. So we have 4, 3, 1, 0, 0, 7. Good. 1, 2, 0, 1, 0, 4. Good. Negative 16, negative 3, 0, 0, 1, 0. Awesome. Okay, so again, our pivot is just this number 4 here, which means I need to make that a 1 and everything above and below a 0. So I'm going to go to Program, and then the Program Pivot. Now notice it's showing you the matrix again, and that number right there, what element is that? Well, that's the first row, first column element. So I'm going to click Enter to ask it for a pivot row. Pivot row is just first row. Pivot column is the first column. Good. Notice it just says done. To see what happened, we have to look at our new matrix, which is now matrix A. And there you go. Notice we have a 1 and everything above and below is 0 there. And just for an indicator for matrix B, or just for reference here, these are the two matrices. Now, A has a bunch of decimals. I don't like seeing decimals, so if I press math and then enter, notice it says answer into a fraction. I don't want that. Instead of answer, I'm going to tell it to do it of the initial, or of the pivoted matrix here. There you go. So I have a 1 there, everything above and below is 0. And then everything else kind of changes. Now notice though, look at the indicators. 0, 9, 4, 0. Those are the indicators. None of those are negative, which means I don't have to do this again. If I needed to do this again, I would need to find a new indicator, or excuse me, a new pivot. And then I would just run pivot again. All right. Well, because we are actually done, I'm going to go ahead and write those down. One, 3/4, 1/4, 0, 0, 7/4, 0, 5/4, negative 1/4, 1, 0, 9/4, 0, 9, 4, 0, 1, 28. Awesome. Well, guess what? I'll see you in the notes. Welcome back to the notes. You can see I have our pivoted, whatever. Our pivoted, still sounds wrong, matrix here. And again, as I was mentioning, these are all positives, or non-negatives I should say, which means that we're done. Now, just to remind ourselves, above these, let's write down our variables of x1, x2, s1, s2, and z. So we had x1, x2, s1, s2, and z. Now, I actually did those different colors because the x's are our actual variables. These are our slack variables, and this is our objective. Now, of these, notice that x2 should be 0, and s1 should be 0. Everything else will be non-zero because a non-negative number, sorry, non-zero number followed by a bunch of zeros, non-zero followed by a bunch of zeros, non-zero, a bunch of zeros. Good. And this allows us to just write down the answer. Or I should say the solution. So we have 1 x1 equals 7/4. Now, I'm not sure if my math lab wants it 7/4 or 1.75, whichever one it asks for. I'm going to go ahead and put 7/4. So whatever x1 was representing, we need 7/4 of them. x2. x2 is 0. s1, 0. s2, we have 1 s2 equals 9/4. So whatever s2 was representing, there are 9/4 of it left over. Then we have z, 1, z equals 28, or in other words, z equals 28. So whatever our objective represented, the maximum is 28, and it occurs when we use 7/4 of whatever x1 represented and nothing of x2. That's really what this is telling us. And what this is also telling us is that whatever s1 represented, whatever constraint that first inequality represented, there's nothing left over of it. And then whatever constraint the s2 represented, there's 9/4 of it left over. Alrighty. Well, there you go. That's pretty much how you solve this system. I'll see you in the next video. Have fun.